So in this video we're going to look at standardising, which means we can transfer any normal distribution to the standard normal distribution with a mean of 0 and a standard deviation of 1. And to do that, we first of all subtract the mean and then divide by the standard deviation. So as a formula, this looks like this. So x is the value that we are using. Mu here is the mean, and this is the standard deviation. So we're going to use this formula here, which might look confusing, but after you've used it a few times, it should make some more sense. So here is an example. You're given the random variable x it's in a normal distribution with a mean of 60 and so the mean is 60 and the standard deviation is 10. And we're asked to find the probability that x is less than 75. So the first thing we'll do is use that formula on the previous page, which was x take away mu, which is the mean, over the standard deviation. So that's what's happening here. So working out the probability x is less than 75 is the same as the probability that z is less than 75, which is what we're trying to find, 60, which is our mean, and 10, which is our standard deviation. So when you work this out, 75 takes 60 is 15, over 10 is 1.5. So now we can use our table to go and read the value of 1.5, and we use this symbol here to write it, phi. I think that's how you draw it. And when you look on your statistical tables for 1.5, you will get the answer here, 0.93319. So here is another example where we're going to use standardisation. So we've got here the heights of an adult female population are normally distributed with a mean of 162 and a standard deviation of 7.5. And we're trying to find the probability that a randomly chosen adult female is taller than 150. So we are trying to work out the probability that x is greater than 150. But we're going to use that formula, the x take mu over sigma. And in this case, this is our mu. Sorry, it's not a very good one. And standard deviation, this is our sigma. So what we're actually trying to work out here is the probability that z is greater than, and now we're going to put this 150 in place of the x, 150, take away the mean, which is 162, divide it by the standard deviation, which is 7.5, and that will give us the probability that z is greater than, once we stick it all in a calculator, and it's going to be negative because we're doing 150 take away 162, and it is negative 1.6. So now we can use our tables to work out the probability that z is greater than negative 1.6, although we don't have negative. So if I do a little sketch, we can see here that what we're actually looking for is 0 and negative 1.6. We can see here that this is the area that we're looking for, which, because of the symmetry, is exactly the same as the probability of it being less than positive 1.6. So if we look on our tables for the value that z is less than positive 1.6, we get the answer, which is 0.9452. So here is another example. This time we have got, I'm going to change colour. This time we have got a normal distribution with a mean of 150, so mu is 150, and standard deviation is 10. And we're trying to find the probability that the next flight from London to Malaga takes less than 145 minutes. So if we standardise that, we're going to say the probability is the same as the probability that Z, so we can use our tables, is less than 145, subtract the mean, which is 150, and that is all divided by 10, which is the standard deviation. So when I put this, well, when I calculate it, or put it in the calculator, but we could do this one in our heads because it is -5 divided by 10, so -0.5. So to put that, or to work that out using the statistical tables, what we're actually working out, here's -0.5, is this bit here, working out what's less than -0.5. And so, even though it doesn't look like it on my slightly dodgy drawing, that is the same as this here because of the symmetry. So the way we'll work this out using the table, because the table always gives us the value less than the number that we're looking at for the area of that. So we will actually say that the probability that Z is less than -0.5 is 1 take away the probability that Z is less than 0.5. So we'll work out, let's go for another colour, this bit here with Z is less than 0.5, and then 1 take away that will give us this bit here. So when we look that up, we are doing 1 take away 0.69146, and that gives us 0.3085. That's the answer. So in this example, we are going to look at this normal distribution with a mean of 30 and a standard deviation of 2. So to standardise it first of all, so we can use the Z values, we are going to say this is the same as the probability that Z is less than 33. Take away the mean, which is 30, and divide that by 2, the standard deviation, and that is the same as the probability that Z is less than 3/2, or 1.5. And we can just go and look on our table for 1.5 and we get the answer, which is 0.93319, or we could round it to 4 decimal places. The second part, similar but slightly different, we are going to start the same or similar. So we're going to say it's the same as the probability that Z is less than 26, take away the mean, which is 30, and divide all of that by the standard deviation, which gives us the probability that Z is less than -2, because 26 take away 30 gives us -4, then divide that by 2 gives us -2. So if we're to draw a little sketch of this, very small here, I haven't got much room, what we're looking for is the bit that's less than -2, so this bit here, if this is -2, and because of the symmetry, you know that that will be the same as this part here. Because we can't use negative numbers on the table, what we'll actually do is work out everything to the left of +2, all this section here, and subtract that from 1 to give us the value that we're looking for. So this is the same as 1 take away the probability of Z being less than 2, and I think that gives us one takeaway 0.9773, which, sticking it into the calculator, gives us 0.9773, 0.0227. Okay, so now we have gone through a couple of examples. Have a look at these, pause the video, and when you think you've got an answer, then you can move on and check your answers on the next slide. And these are the answers, so hopefully you've got them right, and in the next video we'll look at some exam questions.